Isaac Newton. When we think of Newton, the first thing that comes to mind is gravity. The discovery of gravity marked a real turning point in the history of astronomy and physics. Isaac Newton, an English physicist and mathematician, is one of the most notable scientists in history. He was the son of a farmer who died 3 months before his birth, and his mother remarried, which led to a very lonely childhood. He wasn't an exceptional student, but he showed great skill in making things like kites, windmills, and sundials. After completing his primary and secondary education, he was forced to work as a farmer, but through his determined efforts, he eventually began studying at Cambridge University. His exceptional ability in mathematics quickly became apparent. During the outbreak of the plague, when his university closed, he worked from home and made 2 major discoveries. The first was differential calculus, and the second involved infinite series expansions, binomial theorem, interpolation, and finite differences. These discoveries fundamentally changed the field of mathematics. According to legend, Newton discovered the law of gravity after seeing an apple fall while he was in his garden. Are you ready to meet the father of gravity, Isaac Newton? Come this way for all this and more. A tumultuous life story. Isaac Newton is regarded by modern scientists as one of the most influential individuals in the history of science. In a millennial poll conducted at the end of 1999 with 100 leading physicists, Newton was ranked second, just after Albert Einstein, among the greatest physicists of all time. Famous science fiction writer Asimov refers to Newton as the greatest scientist in history. While Newton's laws laid the foundation of physics, his discovery that white light is composed of the colors of the rainbow revolutionized the field of optics. Now let's dive into Newton's life story. Isaac Newton was born on Christmas Day, December 25th, 1642, in the town of Woolsthorpe, near Grantham in England. Born prematurely, Newton was a very weak child, and it was even expected that he wouldn't survive his first days. He was named after his father, a wealthy farmer who had died 3 months before his birth. The name Isaac comes from the prophet Isaac mentioned in both the Bible and the Quran. When Newton was just 4 years old, his mother remarried a wealthy clergyman, and she moved in with her new husband. Newton was left with his grandmother and stayed with her for 7 years. This traumatic experience led Newton to develop a hatred for his family, especially his stepfather. From the age of 12 to 17, Newton lived with the apothecary William, where he developed an interest in alchemy and fell in love with the apothecary's stepdaughter, Miss Story. After his stepfather passed away 7 years later, Newton's mother inherited a large sum of money. Newton started his education at King's School in Grantham at the age of 12. For a period, his mother took him out of school to make him work on the farm, but Newton had no interest in farming. While his mother thought he was working on the farm, Newton spent his time observing the sky and stars, reading books, and taking notes. Eventually, he convinced his mother to let him return to school and prepare for university. At the age of 19, Newton became engaged to Miss Story, the apothecary's stepdaughter. However, as he returned to school during this time, managing both his studies and relationship became difficult. Due to his intense focus on his studies, the relationship ended. After this, Newton never married, and no other relationships are known. It is said that he always remembered this particular relationship. In 1661, Newton enrolled at Cambridge's Trinity College. While continuing his studies, he worked diligently. At Cambridge, the theories of Copernicus and Kepler were largely ignored, and the works of Galileo were not recognized. The philosophy of Aristotle dominated the academic environment. Newton studied algebra, geometry, and trigonometry for 3 years and learned Latin and ancient Greek. During this time, he was greatly influenced by the works of Galileo and Kepler, and also read the philosophical works of Descartes, Gassendi, Hobbes, and especially Boyle. Newton, who took notes on the books he read, wrote in the introduction to his notebook some philosophical questions in Latin. Plato is my friend, Aristotle is my friend, but my best friend is truth. During his years at Cambridge, Newton did not stand out among his peers. He showed his true brilliance during the 2 years he spent at his family's farm, due to the plague. How? Let's talk about Newton's work at the farm. In August 1665, a plague outbreak in London led to the closure of Trinity College in Cambridge, and Newton stayed at his family's farm in Woolsthorpe until March 1667. The 2 years he spent at the farm were very productive, and it was during this time that he began thinking about gravity. His work at the farm laid the foundation for differential and integral calculus. He merged previously used methods for finding areas, arc lengths, and tangents with differential calculus. At the farm, he also managed to create a light spectrum by holding sunlight up to a prism in a dark room, and realized that white light was not a single unit on its own. When the plague ended in 1667 and the university reopened, Newton returned to Cambridge and became a mathematics professor 2 years later. He stayed at Cambridge for about 30 years, continuing his independent work while corresponding with other scientists. During these years, he prepared and completed his greatest work, the Principia book. After observing the flaws in refracting telescopes during his light experiments, he developed a reflecting telescope, which attracted the attention of the scientific world. In 1668, this telescope drew the interest of the scientific community, and in 1672, Newton became a member of the Royal Society. Let's take a small detour here. The Royal Society is an organization with a long history, consisting of experts in the field of science. Only citizens of Commonwealth countries and citizens of Ireland can be members of the Royal Society. Famous scientists such as Newton, Faraday, and Robert Hooke have held its presidency. Now let's close this parenthesis. Isaac Newton published Philosophia Naturalis Principia Mathematica, Mathematical Principles of Natural Philosophy, one of the most important scientific works in world history, in Latin. In the book, he proved all the propositions geometrically and detailed the law of universal gravitation. He also explained that objects attract each other in direct proportion to their masses and in inverse proportion to the square of the distance between them. Newton had a great fear of being criticized and ridiculed, which is why he is thought to have published his discoveries years later. This led to fierce debates with other scientists. He accused Leibniz of plagiarizing his ideas and tried to prevent Leibniz from defending himself using his fame and influence. Newton also had various disputes with physicist Robert Hooke. It is said that Newton waited for Hooke's death to publish the Principia, as the book was published a year after Hooke's death. The book was divided into 3 main sections. The first section praised Galileo's experiments and proved Kepler's laws mathematically. In this section, he outlined the Newtonian laws of motion that bear his name. The second section examined the motion of fluids and proposed the best ship designs. The mathematical study of wave motion in this section attracted the attention of the scientific community. In 1696, Newton accepted the position of Warden of the Royal Mint and moved to London. He took this job very seriously and initiated a major campaign against counterfeit coins. Newton enjoyed living in London and was less involved in academic work. In 1703, he became the president of the Royal Society and held this position until his death. In 1705, he was knighted. In 1706, he was elected president of the Royal Society, and in 1708, Queen Anne awarded him the title of Sir. Isaac Newton passed away on March 31st, 1727, at the age of 84, and was buried in Westminster Abbey. Sir Isaac Newton's groundbreaking discoveries. Newton is considered one of the most influential scientists in history. But what exactly did Newton discover that was groundbreaking? We can't answer this question in just one sentence, because firstly, Newton didn't have just one discovery, he had many. Every single one of his discoveries was groundbreaking, which is why he is regarded as the greatest scientist of all time. Newton was the first scientist to explain the mathematical foundation of planetary motion. Before him, Copernicus and Kepler had made important contributions. However, it was Newton who explained the universal laws of planetary orbits and provided the final answer to the puzzle. Newton derived Kepler's observations through mathematical methods. If we're talking about the law of gravity today, we owe it to Newton. He realized that there was no distinction between the forces acting on the Earth and the forces acting on the heavens. The force that causes an apple to fall to the ground is the same force that keeps the moon in Earth's orbit and moves the planets. According to him, all the motion we observe in the universe could be explained by the universal law of gravitation. Newton understood that the gravitational force between two objects is directly proportional to their masses and inversely proportional to the square of the distance between them. If Kepler's laws were true, then the law of gravity had to follow the inverse square law. He confirmed this theory through various mathematical works. Newton didn't just explain the motions caused by gravity, but also demonstrated that the causes and effects of all types of motion could be reduced to three basic laws of mechanics. These laws are the law of action and reaction, the law of inertia, and the law of force and acceleration. Newton based these laws on Galileo Galilei's work, laying the foundation for his own mechanical theory. Thus, the evolution of any classical system in motion can be modeled and understood using Newton's laws. Whether it's the movement of billiard balls, celestial bodies, or the solar system, it doesn't matter. All classical systems can be understood and modeled using Newton's laws. Newton's classical mechanics remained the definitive theory of physics until the early 20th century and is still the fundamental theory used in all engineering fields today. Like all great scientists, Newton was also curious about the nature of light, and his contributions to optics were more significant and groundbreaking than anything that had been done before. Newton was the first to explain what white light actually is. By using a prism, he split white light into its spectrum and discovered that it consisted of different colors. For the first time, the rainbow had a scientific explanation. He also showed that combining different colors would create white light by rotating his color wheel. Newton's work laid the foundation for spectroscopic analysis, which is now one of the most important tools for understanding the universe. Spectroscopy allows us to separate the light emitted by a source into its colors and identify the elements present in the source. For instance, we can identify the elements that make up stars in this way. Newton argued that light is made up of particles. However, at the time, the wave theory of light was more prominent. It wasn't until Einstein's work on the photoelectric effect that the particle theory of light was supported. Today, quantum theory accepts that light is composed of particles, but its wave-like nature arises as a result of the quantum wave function. One of Newton's most important inventions was the reflecting telescope. This revolutionized astronomy. Galileo had built a refracting telescope, but it had a serious flaw. Due to a problem called chromatic aberration, the light from stars could never focus on a single point. This was because the glass would bend different colors of light at different angles. Since the focus point for red light was different from the focus point for blue light, refracting telescopes could never produce perfect images. Newton solved this issue by using a concave mirror instead of a glass lens. Mirrors focus all colors at the same point. Also, since producing mirrors is easier than producing lenses, larger telescopes could be built. Newton was a mathematical wizard. He solved many problems that had remained unsolved for centuries thanks to his invention of calculus. We owe the concepts of limits, derivatives, and integrals to Newton. Don't wrinkle your faces, smart little ones. Without these concepts, there would be no science, from engineering to physics and astronomy. At the same time, Leibniz also discovered calculus. So who discovered it first? This led to years of debate between the two scientists, but today it is accepted that both independently developed the method. Neither of them plagiarized the other's work. However, Leibniz's notation is more commonly used today, just to mention it. The apple story. You've probably all heard the legendary story of how Newton discovered the law of gravity when an apple fell on his head. But did an apple really fall on Newton's head? The story goes like this. One day, Newton was sitting under an apple tree, stretching his legs and lost in deep thought. But whenever scientists lose themselves in thought, it's only about scientific matters. Who knows what Newton was pondering at that moment and which problems he was trying to solve? Just then, a sweet breeze blew, and one of the apples hanging on the branch swayed back and forth before falling and thudding on Newton's head. Whether his head hurt is unknown, but his eyes suddenly lit up. He first looked at the branch, then at the apple. Excitedly, he shouted, "I found it! I found it!" Wait, no, the stories are getting mixed up. Sorry, that was Archimedes who shouted, "Eureka!" Newton didn't shout, he just smiled. The unexpected fall of the apple inspired him to develop a new way of thinking about gravity. This is how the story of Newton and the apple goes. Isn't it a wonderful story? But what's the truth behind it? Let's dive into that. Newton spent about 2 years in the Lincolnshire village of Woolsthorpe, England, when he was 22, escaping the bubonic plague that killed thousands. During this time, he dedicated himself to solving problems in physics and mathematics. It is thought that the famous apple story happened during this period in 1666, when Newton saw an apple fall to the ground and began thinking about the nature of gravity. There's no evidence that the apple actually fell on his head, but the simple occurrence of an apple falling straight down rather than sideways or upward made him wonder. This event led him to the idea of the universal law of gravity. Newton never told anyone about this event until he was 84, and he never wrote anything about it. However, during a dinner with William Stukely, one of the founders of archaeology, he mentioned the garden and how seeing the apple fall made him think about gravity. When Stukely later wrote the biography, The Life of Sir Isaac Newton, he included this story, which was then spread by word of mouth and became legendary. Furthermore, 3 different authors claimed that Newton told them the same story. However, there were some inconsistencies in the stories. For example, one person mentioned the garden, but didn't mention the apple. Thus, the story of Newton and the apple was retold numerous times. Even Voltaire later got involved, but he referred to the fruit as simply a fruit rather than an apple. Whether Newton discovered the law of gravity because of an apple falling on his head is uncertain, but his insatiable curiosity and desire for discovery are clear from his own words. "I do not know what I may appear to the world, but to myself I seem to have been only like a boy playing on the seashore and diverting myself in now and then, finding a smoother pebble or a prettier shell than ordinary, while the great ocean of truth lay all undiscovered before me." Newton's Prophecies. Looking at the title, you might wonder, was the great scientist Newton a prophet making predictions about the future? Let me explain. Newton, while deeply involved in the physical sciences, also had a strong interest in metaphysical subjects. It's worth noting that Newton was prone to illness and had obsessive tendencies. He worked 18 hours a day, every day of the week, without taking breaks. His work was so consuming that he often forgot to eat, slept very little, and irregularly. There was hardly any time in his life for rest, entertainment, or social and physical activities. He lived in these unhealthy conditions for many years, leading to 2 nervous breakdowns and deep depression. His first depression, triggered by the death of his mother, lasted 7 years. After the second breakdown, he stopped his scientific work. Despite his exceptional intellect, only part of Newton's personal interests lay in the field of positive sciences. After his first nervous breakdown, Isaac Newton withdrew from the scientific arena for a long time and devoted himself to theology and alchemy. Alchemy was one of the popular fields of research at the time, even regarded as the precursor to modern chemistry. For years, Newton searched for the philosopher's stone, believing that it could turn any object into gold. He wrote books to share the knowledge he gained from his alchemical studies. However, because his research coincided with the period when alchemy began to be seen as a pseudoscience, he never published any of these works. In the 1970s, an analysis of a hair sample from Newton revealed that it contained mercury at a concentration 40 times higher than the natural level, showing that his interest in alchemy was not just a hobby. In 1692, Newton began recording his theological research in notebooks that he kept private. He believed that the scientific topics he was working on were also addressed by ancient civilizations before Christianity, and that the sages of ancient times had unlocked the secrets of the universe. Convinced that he could find mathematical clues about the return of Jesus and the end of the world, he tirelessly studied the floor plans of the lost Temple of Solomon in Jerusalem. During this process, he taught himself Hebrew to better understand the original texts. For 50 years, Newton studied thousands of pages on religious thoughts and calculations. When he passed away, he left behind a huge collection of manuscripts containing over 8 million words. These manuscripts passed through the hands of relatives, collectors, and scientists over time. Newton's theological and alchemical writings were kept secret by the Portsmouth family until 1936, when they were sold at a Sotheby's auction in London. The most comprehensive collection of these theological documents was purchased by Iraqi professor of Semitic languages, Abraham Yehuda. After his death, these papers were transferred to the Israel National Library following a controversial process. Fortunately, all of Newton's scientific, theological, and alchemical manuscripts were microfilmed and made available to the public in 1991. As a result, Newton's theological writings were evaluated by a small group of expert scientists, leading to astonishing conclusions. Canadian historian of science, Stephen Snobelin, discovered a piece of paper in these manuscripts on which the famous physicist had calculated the year of the apocalypse. In his complex calculations based on religious references, Newton had selected the year 800 as a significant date. the year of the founding of the Holy Roman Empire. Adding the number 1260, derived from his calculations, he arrived at the year 2060. Yes, you heard it correctly. According to Newton, the end of the world will come in 2060. But don't panic just yet. Newton believed that this would mark the end of an old age and the beginning of a new one. He was convinced that Christ would return and establish a global kingdom of peace. Newtonism. Being a genius is like this. Newton is considered one of the most important scientists in history, and his discoveries in science and philosophy have had a lasting impact for centuries. Those who share his way of thinking are known as Newtonians. Newtonianism is a philosophical doctrine inspired by the beliefs and methods of Isaac Newton, the natural philosopher. While Newton's contributions were in physics and mathematics, his understanding of the universe, governed by rational and comprehensible laws, served as a foundation for many Enlightenment thinkers. Setting aside his scientific and historical views, Newton was a devout believer in sacred texts. He reconciled his beliefs by adopting the view that God established the mechanical laws of nature at the beginning of time, but retained the power to intervene and alter them at any time. He also believed that the preservation of nature was a direct action of God. He stated that the sun and the fixed stars constantly needed a miracle to prevent them from colliding through gravity. While some members of the religious community reacted to Newton's non-Trinitarian beliefs about God, others believed that science, when properly applied, would lead to a greater understanding and appreciation of God. These views influenced many Enlightenment thinkers and scientists, including the French writer and philosopher Voltaire. Between 1726 and 1729, during his exile in England, Voltaire learned Newtonianism from many English thinkers. When he returned to France, he published Lettres philosophiques and Philosophie de Newton. Voltaire's friend published a French translation of these books, which became a great success in France. At this point, the question of Newton's religious affiliation may arise. While we identify Newton as a scientist, he described himself more as a theologian. He was Christian, but a Christian who rejected the doctrine of the Trinity. In other words, he was a monotheistic believer. He believed in a God who performed miracles in creation and maintained the universe at every moment. Newton, who argued in favor of God's existence, saw his own scientific work as a religious endeavor and regarded the universe as God's second book. In his famous work, Newton referred to God many times. A deeply knowledgeable scholar of the Bible, Newton rejected the Trinitarian belief that most Christians upheld. He declared that God was one and that the doctrine of the Trinity was a fabrication by early Christians. Newton and the Philosopher's Stone. As mentioned earlier, Newton spent a significant period working with alchemy. Many of his alchemical experiments were aimed at the search for gold. Alchemy is a term that refers both to the primitive methods of investigating nature and to an early spiritual philosophy. Alchemy includes chemistry, metallurgy, physics, medicine, astrology, semiotics, mysticism, spiritualism, and art. With a history of at least 2,500 years, alchemy held a significant place in the civilizations of Mesopotamia, ancient Egypt, Persia, India, and China. The modern profession of alchemy is now known as chemistry. Most alchemical experiments of the time aimed at producing gold. Newton designed numerous alchemical experiments with this goal and kept records of his findings. The mercury mentioned in his notes was also known as philosophical mercury. It was believed that philosophical mercury could break down many metals into small pieces to produce new metals. This was considered the first step toward making the Philosopher's Stone. According to legends, the Philosopher's Stone could turn metals into gold. Given the goals of alchemical work at the time, the Philosopher's Stone was of immense value. Alchemists believed that metals were compounds, and by altering the proportions of the components that made up the metal, a new metal could be created. Another interesting aspect of Newton's notes is the additional comments he made. Newton had added his notes to parts of documents from an American alchemist. According to Newton, some of the measurements and ratios in these instructions were incorrect. As a result, he corrected these inaccuracies and made small notes on the instructions. Additionally, Newton kept notes on an experimental system he designed to extract essence from lead ore. Unfortunately, there is no evidence in these notes that Newton actually made the Philosopher's Stone or that he used a specific ratio of mercury to make it. Nevertheless, these notes provide evidence that alchemy was an influential aspect of Newton's work. One other notable feature in the notes was the mysterious American alchemist Newton was following. The notes connected Newton to this alchemist, suggesting he closely followed and respected his work. This mysterious alchemist was none other than Irenaeus Philalethes, better known as George Starkey. Starkey was America's first world-renowned scientist. Approximately a century before Benjamin Franklin's work on electricity, Starkey emerged in the 1600s for his work in alchemy. Later, he moved to London, where he continued his work, inspiring famous scientists like Newton, Robert Boyle, and John Locke. Starkey also authored many books under a pen name. Referring to himself as the dearest lover of truth, Starkey kept his true identity hidden, so much so that even those influenced by his work did not know who he truly was. The reason Newton's work in alchemy remained in the background was due to the bad reputation alchemy had acquired in later years. By the end of Newton's life, alchemy had gained a very poor reputation. Here are 7 interesting facts about Newton. Each piece of information about Newton could be intriguing, but let's pick out the most interesting ones and share them with you. Fact 1. Isaac Newton, one of the geniuses of the 17th century, observed the formation of a color spectrum when sunlight passed through a prism from a small hole in a dark room when he was just 23 years old. So in fact, Isaac Newton didn't enter our lives with an apple. He was indeed the father of gravity, but he was a much greater genius than we usually realize. Fact 2. Newton had an unhappy childhood. Isaac Newton, born in 1642, lost his father before he was born. His mother left him when he was 3 years old. When she returned, Newton was 11, but she didn't come back alone. She had new children and a new husband. Newton, who had an unhappy family life, found his only escape in his endless curiosity and science. Fact 3. Newton was a poor student in school. He entered Trinity College at Cambridge in 1661. Despite all of his discoveries and knowledge, he was a failure in his university life. No one referred to him as a genius during his school years. His real success came after his school years. Fact 4. Newton was not only a scientist, but also an inventor. He invented the reflecting telescope. As a great physicist and mathematician, Newton was also interested in astronomy, and he became the inventor of the reflecting telescope. Fact 5. Newton was even accused of theft. How? Isaac Newton had solved the mystery of the light spectrum. However, Hooke claimed that this knowledge was his own and accused Newton of stealing it, calling him a thief. After this unpleasant incident, Newton withdrew into isolation in his house in Cambridge. Fact 6. Newton, being a very introverted person, particularly after his argument with Hooke, secluded himself and began studying ancient Greek philosophers and geometry. During this period, Newton dealt with unanswered questions about matter and space-time. Newton was not a social person. He mostly spent time alone. Fact 7. A few months after Robert Hooke's death, Newton was appointed as the president of the Royal Society. The Royal Society had pictures of great scientists. The rumor is that one night, Newton, seeking revenge on Hooke, threw his portrait into the fireplace and burned it. Of course, this is just a rumor. This could be a small piece of gossip, whether you believe it or not. Theologian Newton. Newton discovered the law of gravity and the three famous laws of motion that bear his name and formulated them mathematically. He mathematically demonstrated that planets should move in elliptical orbits and that the Sun should be at the center of our system, thus ending the Earth-centered view of the universe. Before Newton, under the influence of Aristotle, it was believed that the laws of the sky and the laws of the Earth were different. Newton showed that the laws of physics were universal. Moreover, Newton also demonstrated that light's structure was not homogeneous, discovered the color theory, and explained reflection and refraction by uncovering the particle nature of light. He improved the reflecting telescope, enabling better observations. All of this shows us his scientific side. However, there is another lesser-known side to Newton, which is that he was a theologian, a philosopher of religion, and a historian of religion. Newton, who worked 18 hours a day, spent much of his time on theology rather than science. A large portion of the recently collected Newton manuscripts consists of religious writings. The reason his theological side remained hidden was that he never shared his religious writings with anyone except his close circle. Newton's claims in theology were extremely dangerous during his time. Newton claimed that neither the Catholic nor the Anglican Church defended true Christianity, and that these religions emerged as distortions of true Christianity. He rejected the doctrine of the Trinity, arguing that it was a clear insult to God. He rejected the claim that humans had an immortal soul, asserting that God would resurrect humans along with their bodies after death. He believed that Satan was not a being, but a metaphor for a person's bad side. All of these were things that were forbidden to express during Newton's time. In fact, people who rejected the Trinity could be subject to severe punishments, including death. Because Newton rejected the Trinity, at best, he would have been expelled from university. Indeed, in 1710, William Whiston, who replaced Newton at Cambridge, was dismissed for rejecting the Trinity. Newton never married and dedicated his entire life to his work. He never played as a child, instead building various windmill and car models and reading books in his stepfather's library. He especially surprised all his friends and teachers with his deep knowledge of the Bible. When he turned 14, Newton had to return to the farm to care for his mother, who was widowed again, and his 3 younger siblings. He had to leave school and work on the farm. However, his teachers intervened, convinced his mother, and provided a scholarship to send him back to school. This event deeply affected Newton and soon made him the best student. Newton then continued his university education at Cambridge's Trinity College. To financially support himself, he worked for hours each day in various jobs, helping his professors, distributing food, etc. He didn't show interest in Aristotle, as was taught at school, but instead read new thinkers like Descartes, Galileo, and Kepler, which drew the attention of his professors at Cambridge, though he appeared as an ordinary student. From his notebooks, it appears that he began to show interest in theology during these years. At that time, he opposed Descartes' mechanistic view of the universe because it disregarded God. Indeed, his scientific project was based on the idea that God was active in the universe. When Newton graduated in 1665, the plague broke out. Due to the plague, school education was suspended, and Newton, who had planned further studies, had to return home. During his time at home, he continued his work in mathematics and developed the famous binomial expansion. During this period, he also found the idea of gravity and began working on his theory of gravity. These were also the years when Newton's interest in theology increased. He started studying ancient texts to determine whether the Bible had been corrupted. During this period, he concluded that the Trinity did not exist in true Christianity and believed that this idea arose as a result of corruption within Christianity. In 1667, Newton returned to Cambridge for graduate studies and began teaching there. During this period, he made serious studies on optics. In 1672, he became a member of the Royal Society and presented his telescope. By then, he had completely severed his ties with the Catholic and Anglican churches. He believed that current Catholicism had been corrupted. However, all professors at Cambridge's Trinity College were required to be appointed as Anglican priests by the end of their 7th year. It was unacceptable for Newton, who rejected the Trinity and considered the Anglican Church to be heretical, to hold such a position. Therefore, Newton decided to go to London and speak with the king, as the only way to escape this appointment was if the king allowed an exception. However, King Charles II had never granted such a right before. After 6 weeks of effort, Newton got what he wanted and avoided being appointed as a priest. In 1687, his revolutionary work, Principia, was published. Newton was elected to the English Parliament in 1689 and 1690. During this period, he became seriously interested in alchemy. Many years later, he conducted experiments that would later be repeated by important chemists. Unlike other alchemists, Newton was not interested in turning metals into gold to become rich. His goal was to understand how God created the universe and life through alchemy. In 1690, he fell ill from overwork, and after that, he focused more on the Bible than on natural sciences. He prepared an unpublished text addressing the Trinity, which he sent to the famous philosopher John Locke, who also did not believe in the Trinity. During this time, he wrote religious books, but never published them. After his death, in 1733, his books Observations on Daniel and the Revelation of St. John, and in 1754, Historical Reasons for Two Notable Corruptions in the Bible, were published. Newton's theological persona is still not widely known by the public today. However, Newton wrote more on theology than on alchemy and science. Newton wrote about 1 million words on alchemy and about 3 million words on religion and religious history. His writings in the fields of science and alchemy were primarily to understand God and creation. For Newton, there were two ways to gain knowledge about God. The first was through the sacred scriptures, and the second was by observing nature, which was God's other creation. The phrase "God is known through his works" summarizes Newton's philosophy of science. According to Newton, the ultimate goal behind natural sciences was to understand God, and that is why he engaged in both science and alchemy. Newton believed that religion and science would never contradict each other. Therefore, he believed both science would guide religion and religion would guide science. Newton believed that if we looked at the universe objectively, we would see design and find God through this design. Even as a university student, he argued that the symmetry in living beings could not be explained by chance, but rather as a work of design. During his correspondence with Bentley, Newton said that the structure of the solar system could only be explained by a superior creator, and he repeated the same view in the general explanation section of his groundbreaking Principia, the final words of Newton. As we approach the end of our book, let's leave the floor to Sir Isaac Newton and listen to his philosophically profound words. Please, Mr. Isaac Newton, the floor is yours. If I have seen further, it is by standing on the shoulders of giants. People are like numbers, and their value is measured by the number they are part of. Plato is my friend, Aristotle is my friend, but my best friend is truth. God has created everything with measure, weight, number, and length. If we disregard all other evidence, even the thumb is enough for me to believe in the existence of God. No great discovery was ever made without a solid hypothesis. We are not our thoughts. We are the thought of our thoughts. If I had waited for others to do something for me, I would have achieved nothing. I can calculate the movements of stars, but not the madness of people. It is very difficult to explain all of nature, even for anyone or any era. For every action, there is an equal and opposite reaction. Love is about building bridges. People stay lonely because they build walls where they should build bridges. The quality of your life is determined by the quality of your relationships. Conclusion: it is almost impossible to imagine the world of science without Newton. The English physicist, mathematician, and astronomer Isaac Newton is one of the most important figures who laid the foundations of modern science. Living at the turn of the 17th and 18th centuries, Newton is best known for formulating the law of universal gravitation and laying the groundwork for differential and integral calculus. Additionally, his major contributions to optics, the laws of motion, and astronomy changed the course of science history. Newton's disciplined and systematic approach to science laid the foundation for modern scientific thought, and his discoveries deeply transformed our worldview. The most significant inventions that Isaac Newton contributed to the world of science are reflecting telescope. In 1668, Newton invented the reflecting telescope. Unlike traditional telescopes that rely on lenses, this one uses mirrors. Newton succeeded in reflecting light using mirrors, thereby creating a telescope capable of collecting more light and with a larger aperture. This invention allowed for sharper and more detailed astronomical observations. Prism experiment. Newton is also famous for his optical experiments to understand the nature of light. One of his most famous experiments is the prism experiment, which demonstrated that white light splits into colors when passed through a prism. In this experiment, Newton passed white light through a prism and discovered that the light splits into different colors, each corresponding to a specific wavelength. This work led to important advances in understanding the fundamental properties of light and optics. Law of universal gravitation. One of Newton's most famous discoveries is the law of universal gravitation. He discovered that the force of attraction between objects exists, and that this force is a function of mass and distance. This discovery explains why objects fall to the ground and how the planets move in their orbits. The law of universal gravitation is one of the cornerstones of classical mechanics and remains a key principle in modern physics. Differential and integral calculus. Newton also made significant contributions to mathematics. He made great advances in the fields of differential and integral calculus. By using a new mathematical method, Newton took an important step in calculating the slopes of curves and areas under them. This work formed the basis for the differential and integral calculus, which is a fundamental principle in modern mathematics. Isaac Newton had extraordinary intelligence. and a keen understanding. He had an exceptional ability to solve mathematical problems and understand complex physical phenomena. His deep thinking processes and analytical approach enabled him to provide solutions to complex problems, making him a genius scientist. Newton served as a member of the British Parliament for Cambridge University in 1689 and 1701. In 1696, he became the director of the Royal Mint and later the Master of the Mint. With this title, he became the most senior person at the Royal Mint. In 1703, he became the president of the Royal Society and joined the French Académie des Sciences. In 1705, during a visit to Trinity College, Queen Anne knighted Isaac Newton. He was later knighted again by Francis Bacon. Newton carried out his scientific discoveries with a systematic work method. He carefully studied the subjects he was interested in, gathered data through observations, and organized his thoughts in a systematic manner. His disciplined approach ensured that his scientific work produced strong and consistent results. Newton was a curious and passionate seeker of understanding how the world works. He constantly performed experiments and sought new discoveries to unravel the mysteries behind natural phenomena. His curiosity and desire to explore led him to pioneer scientific progress. Newton had a dedicated work discipline when it came to science. He worked long hours, conducted experiments, and developed theories. Through rigorous observation and mathematical analysis, he worked tirelessly to obtain results. This intense work ethic and dedication led to his remarkable scientific discoveries. Newton was a scientist who questioned existing knowledge and challenged prevailing theories. His innovative thinking and bold approach enabled him to make new discoveries and bring fresh perspectives to existing paradigms. Change and innovation were key factors in Newton becoming one of the pioneers of scientific revolutions. On March 31, 1727, at the age of 84, Mr. Newton passed away in his sleep at his home in London. He was buried in Westminster Abbey, where other significant figures like Charles Darwin, Charles Dickens, and David Livingstone are also buried. It is believed that Voltaire gave a speech at his funeral. We remember him with reverence and are deeply grateful for the valuable contributions he made to humanity.